All right, welcome to section 1.6. I think this is the first section in chapter 1 that only has one part. So this is called function operations and compositions. And it's only one part because most of this is review. You should have already done this, okay? So the essential question is, what are function operations and compositions and how are they used? All right, pretty simple. What you're going to learn, how to perform operations on functions and how to find compositions of functions. Okay, so remember this whole chapter is talked about this main word that was a nice one. This main word functions and what it does, what are some properties, what the graphs looks like, things like that. So this whole chapter is a culmination of everything about functions. Okay, so now we're going to learn how to do operations on functions and how to do compositions on functions. All right, so the operations that we are going to talk about, we have some. So this is the form of what functions look like when you're adding them. So this is saying you're going to take your f function and you're going to add it to your g function. So, or we could write it f of x plus g of x. Okay. Difference, meaning subtract, is we are going to write it with a subtraction sign, which means we're going to take our f function and subtract our g function. All right. Then we have product. So we write product f times g of x, which just means we're going to take our f function and multiply it by our g function. And we're just talking adding, subtracting, multiplying, and dividing here. This is exactly all we're talking about. So we have f divided by g of x, which for quotient stands for divide. So really this is just f of x over g of x. Okay, so those are our four operations. That's what we're going to do on some examples on the next page. Okay, all right, it says find the following operations with the given functions. So we have f of x, we have g of x, we have h of x. All right. So we just have to pay attention to what letters it's asking us to do. So this first one says we're going to take f and we're going to add it to g. All right, so f is x squared plus 4x, and we're going to add it to g. Our g is square root of x plus 2. Now this is kind of strange because we're thinking, well, can I add this 4x to my x inside the square root? You cannot add over a square root symbol. So really, there's no like terms here, there's nothing I can do. So this is our final function. Okay, all I did was add them together. There's nothing I can simplify there, and that's it. X squared plus 4x plus square root of x plus 2. All right, second one, there is a little bit more work we can do. Okay, let's do this one in green. So it says take f, which is this one, and subtract h, which is this one. So x squared plus 4x, that's f. And we're going to subtract. Now with subtraction, we're going to use some parentheses because we're going to have to distribute this negative. So 3x plus 5 is my h. So that's what I'm going to put in the parentheses. All right, so let's do our like terms. We only have 1x squared, so I'm going to bring that down. So that one's done. We have 4x minus 3x, which is 1x. And then we have a minus a 5. So we have to do minus 5. Okay, so as long as you're fully simplified, there is our final answer. So we took our f and we subtracted our h. That's what it told us to do. Take f, subtract h. So x squared plus 1x minus 5. All right, so this is still example 1. They're still the same three equations, but now we're going to do a multiplying and a dividing. Okay, so let's see what we get here. So the first one says take f, which is f, multiply it by h, which is right here. So we're going to take f, x squared plus 4x, and we're going to multiply it by 3x plus 5. And I put it in parentheses because we're putting them right next to each other, so it's a little bit easier to look at. So now a binomial times a binomial, we need to FOIL. Okay, so x squared times 3x is 3x cubed. X squared times 5 is 5x squared. 4x times 3x is 12x squared. And 4x times 5 is 20x. All right, so let's see what we have here. So I have a 3x cubed. That's done. 5x squared plus 12x squared is 17x squared. And then we have a plus 20x. Okay, so there is our multiplying of two functions. All right, so then the second one here wants us to do a division. It's saying take h, which is right here. So 3x plus 5 and divide it by f, which is x squared plus 4x. Now, when you're thinking about dividing, you have to see, is there anything I can factor out? All right. The top, there's nothing that they share in common. The bottom each have an x. But when I take an x out, I get x plus 4, so there's really nothing to cancel here. So if there's nothing to cancel, nothing to simplify, then you're just done. 3x plus 5 divided by x squared plus 4, x. Okay, so that's how you divide. So we're just adding, subtracting, multiplying, dividing functions together. It's really that simple. All right. So part 2 of this section is called composition of functions. This means we're going to combine functions together. So here is a function y equals x minus 3 squared. And we can think about this as being a composition of y equals x minus 3 and y equals x squared. If I take x minus 3 and put it in for x, we would get x minus 3 squared. So x minus 3 squared is a composition, a compound. So what's a compound in science? A compound is a mixture of 2 or more elements. Well, a composition of functions is 2 or more functions going into one. All right. Now we can write composition in two different ways here. This symbol right here means compose or composition. Okay, that's not a multiplying, that's a compose symbol. So this says in words f of g of x. Okay, same thing here. This says f of g of x. And this really won't make any sense until we see some examples and how this works. So what it means to compose. All right, so let's look at example 2 here. We have two functions. We have f of x equals x squared plus 1 and g of x is x minus 4. This first one says we want to do f of g of x. Now, the trick with these is you always start at the right. So I'm taking my g function and I'm going to plug it into my f. So I'm going to take my g function and I'm going to plug it into my f wherever there is an x. Okay, so x squared plus 1. So my new x is x minus 4. I'm going to square it plus 1. Okay, now we have to FOIL this, x minus 4 squared. So x minus 4 times x minus 4 plus 1. So x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16, and then I have a plus 1. Okay, so let's simplify, and then we've done our composition. So we have x squared. Negative 4 plus a negative 4 is negative 8x. 16 plus 1 is 17. Okay, so there is our composition of functions. We did f of g of x. Now it wants us to reverse the process. So let me get rid of this writing here. All right. Now it wants us to completely reverse the process. Now it wants us to take f of x and plug it into g. So we're going to take f of x. We're going to plug it into g where there's an x. Okay, so x minus 4 is what I'm working with. So I'm going to put the minus 4, but what's my new x? X squared plus 1. Okay, so what do I have to simplify here? Bring down the x squared. 1 minus 4 is negative 3. So x squared minus 3. All right, so that's how we compose g of f of x. Now, that's when we're just plugging a function into a function or the other function into f. The next part of the example, so these are the same equations. Now we're going to actually plug numbers in to see what happens. All right, we're still starting at the right. What this is saying is I want to plug 2 into g. Okay, I'm going to plug 2 into my g function. So I'm going to do g of 2. This equals 2 minus 4. That's equal to negative 2. Now, so for this problem right here, I got an answer of negative 2. Now that answer is now going to go into the next one, which is f. So I'm going to plug negative 2 into my f function. So negative 2 squared plus 1. Negative 2 squared is 4 plus 1, which is equal to 5. Okay, hopefully that makes sense. So let's do one more example. Hopefully that makes a little bit of sense here. All right, so we're going to do one differently here. We're going to take 3 and we're going to plug it into f. So 3 is going to go into f. So 3 squared plus 1, which equals to 9 plus 1, which is 10. So this answer is 10. Now this answer is going to go into g. So 10 is going to go into g. 10 minus 4 is equal to 6. So my final answer is 6. Okay, I think that's pretty easy. I think this is review for some of you from Algebra 2. We'll do some more examples in class, but hopefully that makes some sense. I will see you tomorrow. Have a good night.